Okay, here's our 9.3 Solving Rational Equations video. We are going to go back to 9.1 just a little bit, but it's really not even going to be helpful once you see what 9.3 is. So the two things that I want you to remember our first step, anytime we're doing any of these rational problems, is always going to be to factor, and that includes taking out a GCF if you need to, so includes GCF. Remember our kind of shortcut or our cheat that we did today on our calculator. The second thing, just like we've been doing, is going to be naming our excluded values. So our excluded values. And then we're going to see how solving equations is going to be different. So after that, we're just going to skip to our step where we're going to solve the equation, and you're going to see what that looks like and if there's anything else we need to check. So let's look at one example. Okay, so notice on this example, it's an equation, right? There's an equal sign in the middle, so we're not multiplying anything or dividing anything quite yet. We're going to actually be solving. Okay, so the first thing that I want to do is factor any of these that can be factored. Notice that the only one that can be factored is this 2x minus 10 on the bottom. So I've got 3x plus 7 will stay the same, x minus 5 equals, and then I've got 5x plus 17 is the same. I can take a 2 out here, which is going to leave me with x minus 5 if I divide that. You could go ahead and put all the rest of these in parentheses if you like to do that, if that makes it easier for you. I think that you're going to like the way that that looks a little bit better. All right, so that was my first step, was to factor. So my first step. And then my second step, remember, is going to be excluded values. So I'm only looking at the denominator. Look at all the denominators, but since these have the same part in it, the only excluded value is x cannot equal 5. Okay. Okay, so now we need to solve the equation. And if you think about it, I don't know about you. Actually, I probably do. I don't think you all are the biggest fan of fractions. So the idea would be if we could eliminate the fractions as they stand. So I'm just going to, let's look here at our two fractions. We want to eliminate. Remember that fraction bars mean division. So to undo the division, we have to multiply, and we have to multiply everything. So you may want to make just a little star in your notes. To undo division, we need to multiply. All right, so if we look at our equation, notice that I need to undo this x minus 5, this divided by x minus 5. So I'm going to multiply every single thing by x minus 5 on the top. All right, so when I say every single thing, I am talking about each of these fractional parts. Okay, remember that the whole point of that was to undo the division. So the x minus 5 cancels there, and it's going to cancel here. So I'm going to rewrite. I know this is going to kind of look weird. I'm working in a weird order. I'm going to rewrite what I've got left. So now I have 3x plus 7. And 5 equals 5x plus 17 all over 2. Okay, now I still have a denominator somewhere. I've still got a fraction, and that's obviously this divided by 2. So to undo that, I'm going to multiply everything by 2. Well, right here, they cancel to eliminate the fractions. And on this other side, I have 3x2 times 3x plus 7 equals 5x plus 17. All right, now I'm just in the business of solving. So the whole purpose, notice that I multiplied to undo the division. And now you can put a note. Now we're just going to solve. And this should be a lot easier. This is just regular, normal math. All right, so got to distribute. That's going to give me 6x plus 14. There's just a 1 distributing on this other side since there's nothing written there, so that's just 5x plus 17. If we solve that, that gives me, I'm going to subtract 5x from both sides, minus 5x, So that's 1x plus 14 equals 17. minus 14, which is going to give me x, 1x, or just x equals 3. And the only other thing that you need to do, so this is the last little star you're going to put on this example, you need to check for extraneous solutions. So what that means, I know that's kind of a weird word, what that means is we need to check that this answer or any of the answers we get here are not part of my excluded values, and they aren't. So the final answer here, I'll put a big yellow box around it just so we can see. Our final answer to this problem is just x equals 3. All right, let's look at another one. Okay, so let's remember our first step is to factor anything that needs to be factored. Notice that this time we have 3 fractions. 1, 2, 3. I'm just circling those so that you see them. I don't think any of that needs to be factored. There are no GCFs, nothing to type in our calculator, so we're going to leave them the same. So I'm just going to say, check, I did my factoring. The second thing we need to do is name any excluded values. Remember, we look at the denominators there. So the only place I see that is this x minus 7, which is happening 2 times. So the excluded value is that x cannot equal positive 7. All right, now we need to, so now we're on to our solving step, and we need to eliminate our fractions. So to do that, to eliminate our fractions, we're going to have to multiply by the denominators. Okay, so one of the denominators I need to get rid of is this x minus 7. To undo the division, I have to multiply every single fraction by x minus 7. X minus 7 times x minus 7. Notice that when I do that, they're going to cancel where the denominator is already x minus 7. So now my equation, I'm going to rewrite. I've got 2x minus 9 plus x, parentheses, x minus 7, over 2, the denominator is still there, equals 5. All right, now I've got another step where I need to eliminate this 2 denominator. So I'm going to have to multiply every part or every single thing by 2 times 2. Okay, in the middle here, again, my multiply by 2 and divide by 2 are going to cancel each other. So now my problem is going to read 2x minus 9 equals x times, not equals, plus x times x minus 7 equals 10. All right, make sure you understand the multiplication I did right here to eliminate denominators. All right, now we're just on to a regular problem that we want to solve. So I'm going to scroll up here. So I'll change over to blue. So we're just got to distribute here, distribute there. 4x minus 18 plus x squared minus 7x equals 10. And you may notice the difference here is that we've got x squared. So if you have x squared, I'm just going to put a little star, but you need to write this note out. If you have x squared, make the entire equation equal 0. All right, so let me show you what I mean by that. I'm going to combine some things that I can combine. So now my problem's, and I'm rearranging x squared minus 3x minus 18 equals 10. So all I did was rearrange the left side and combine like terms. And then I want it to equal 0. So I'm going to have to move this 10 over. So subtract 10. So now my equation is going to read x squared minus 3x minus 28 equals 0. All right, so now we've got a quadratic, so we're just going to go ahead and solve that using factoring. We know that's going to be the quickest method. So I'm going to just set this up. Top number is negative 28, bottom number is negative 3. I'm pretty sure that's going to leave me with 2 numbers of negative 7 and positive 4. So my factors are going to be x minus 7, x plus 4, which is going to give me 2 possible solutions of x equals 7, and x equals -4. And the other thing we want to do is check that those excluded solutions we included in the beginning, and in fact we said that x could not equal 7. Remember, so since x can't equal 7, that's not an answer, and the only actual solution to this problem is that x equals -4.